Let's look at the solutions of quality quant questions, week 22. This week, we'll be taking up questions on polygons and quadrilaterals. Right? Okay, let's start. ABCD is a parallelogram whose diagonals meet at E. The perimeter of ABCD is 120. The perimeters of the triangles BCE and CDE differ by 40. Find the sum of the squares of the diagonals of ABCD. Okay. So if I draw a parallelogram, something like this, I know a perimeter, I will name it as A, E, C, and D. And then let me also join their vertices. For parallelogram, I know that their diagonals are bisected. So if this length is A, this length is A, and if this length is B, this length is B. Additionally, I'm taking this length as M and this length as N. AB is M and BC is N, which should mean AD is also N and DC is M. Perimeter of ABCD is 120, which means 2M plus 2N is equal to 120, or M plus N is equal to 60. This is known. The perimeters of triangles BCE. This is where their diagonals meet. BCE perimeter would be A plus B plus N, and CDE. CDE, their three sides are A plus B plus N. Their perimeters differ by 40, which means the difference of these two is 40. A minus A gone B minus B gone N minus N is equal to 40. I have M plus N is equal to 60 and N minus M equal to 40, which will lead me to N being equal to 50 and N being equal to 10. Okay, this is not. Now, find the sum of squares of the diagonals of ABC. Sum of squares of the diagonals of ABC. How we go about it, how we should go about doing it is, let me extend this line of B till here and BC extended here. Now, let this be K, let this be W. This point I'm labeling as N. So Cn is W and Dn is K. In the same vein, can you see if I were to make this from A, if I drop a perpendicular and I'm naming this point as N, Dn will also be equal to W and Am will also be equal to K. Now, just to be certain that we don't mess up, I'm going ahead and also doing this. This entire length is smaller. Okay. Now, for N, sorry, can I say by diagonal AC, AC square should be equal to K square. The triangle I'm looking at is this one. AC square is equal to K square plus M minus W square. And BD square. The triangle I'm looking at now is this one. So BD square will be equal to K square plus M plus W square. m square plus w square, m plus w whole square. So AC square plus BD square is equal to k square 2k square plus or plus m square plus w square minus 2mw plus 2 plus m square plus w square plus 2mw. These two terms will cancel each other out. We will be left with 2k square plus 2w square plus 2m square. Now, look at the triangle BCN. Look at this triangle. Can I say k square plus w square is equal to x square? So, I can rewrite this as 2 times of n square plus m square. N and m values I already know. So, 2 times of 50 square plus 10 square, or altogether we'll get 2 into 2600, or the answer will be 5200 for this question. Now, the wonderful thing here is, I have deliberately taken the longest path to reach the answer and broken down everything. You can perhaps reduce your work here. You can reduce your work here by simply doing this. The question stated ABCD is a parallelogram whose diagonals meet at E. The perimeter of ABCD is 120 and the perimeters of triangles BCE and CDE differ by 40. It was a parallelogram. Do we know any standard parallelograms? Very much so. The best standard parallelogram we are aware of is rectangle itself. Now, given that the perimeter of the rectangle is 120, perimeter of the rectangle is 120, I can go ahead and say this is A, and in rectangle, all the diagonals are of equal length, so they will get bisected in equal parts. If this is M, this is N. Can you see? You would get M plus N is equal to 60. And let's call this A, B, C, and D. And this will be E. Can you see? Perimeter of BCE will now be 2A plus N, and for CDE, it will be 2A plus M. So N minus M is equal to 40, or N is equal to 50, M is equal to 10. As soon as you arrive at that conclusion, now the diagonal lengths can easily be identified as find the sum of squares of the diagonals of ABCD. AC square will be equal to 50 square plus 10 square. BD square will also be equal to 50 square plus 10 square, or altogether their summation will be equal to 2600 into 2, or 5200. Why assuming this parallelogram being a rectangle is fine is we are not violating any condition given in the question, and we have reimagined a simpler diagram. This idea where you can reimagine a simpler diagram, as long as you're not violating any rule of geometry and you're not violating any condition given in the question, you can always reimagine a simpler diagram, which in this case is turning out to be true. And this idea or this line of thought is known as deformation. Okay, next question. The adjacent sides of a parallelogram are 21 and 13. If one of the diagonals is 2 root 105, find the length of the other diagonal. Okay, let's say this is the parallelogram. This is 21, this is 13. Now, that will be from one diagonal. Let me draw the other diagonal. Okay. Now we are told one of the diagonals is 2 root 105. We know diagonals in a parallelogram get bisected. So this length here should be under root 105. Now look at triangle A, B, C, D, and O. Can you see for triangle ABO, AO is the median. AO is the median, and therefore we can happily apply Apollonius theorem. We will have AB square plus AD square is equal to 2 times of BO square plus AO square. Now AB square is 441. AD square is 169. BO, see, AC was 2 root 105, so AO will be root 105. BO square, we don't know. Plus AO square will be 105. So we get 610 is equal to 2 BO square plus 210, or BO square, 2 BO square is equal to 400, or BO square is equal to 200, or BO is equal to 10 root 2. This length here is 10 root 2. We know diagonals are bisected. So the length of OD will also be 10 root 2. Or the length of the other diagonal in entirety will be 20 root 2. Option D. Okay. Next. ABCD is a rectangle where AB is greater than BC. Okay. A, B, C, and D. The perimeter of ABCD is 34. So can I say, let this be L, let this be B. So L plus B, 2 times of L plus B is equal to 34, or L plus B is equal to 17. Additionally, area of the triangle ABC is 30. Area of triangle ABC is half the area of the rectangle. So if this area is 30, this area is 30, area of the full rectangle is 60, which means L into B is 60. So now, utilizing these 2 points of information, L plus B is 17 and L into B is 60. Hopefully, we have done enough number of algebra questions to get to the conclusion. L is equal to 12, B is equal to 5, or vice versa. L is equal to 5, B is equal to 12. That is immaterial. We can do that. L is equal to 5, 12, and B is equal to 5. L has to be greater than B. No, we also add that information. AB is greater than BC. So we get to our value of L is equal to 12, B is equal to 5. And then this is wonderful. Let me do this. Okay. Next thing we are told is D is a point on CD such that CP is to PD is 1:3. CP is to PD. Remember, this length is 12. We have identified 1:3 would mean I have divided it into 4 equal parts. This is 3. This here whole thing is 9. Find the distance from P to the intersection points of the diagonals of ABC. Okay, I shouldn't have removed the diagonal then. This is one diagonal. This is another diagonal. Now, if I look at the intersection point of the diagonals, from here, this will be point P, of course, 3 and 9. From here, I will come down to the midpoint of this side CD. So this length here is 6, of which BC is 3. So PO, I'm calling this PO, will also be 3. Additionally, OE, OE will be half of B, which means it will be 2.5. If I'm looking for length of EP square will be equal to 2.5 whole square plus 3 whole square, or EP square will be equal to 25 by 4 plus 9, which is equal to 61 by 4, or EP will be equal to under root 61 by 2, which is option D. Okay. Next question. A rhombus has a perimeter of 40 centimeters. The line joining the midpoints of two adjacent sides is 6 centimeters long. Find the area of the rhombus. Okay. A rhombus has a perimeter of 40 centimeters, which means the length of every individual side is 10 centimeters. Now we are told the line joining the midpoints of two adjacent sides is 6 centimeters. So this here is 6. Now I'm also going ahead and joining the diagonals. We are told this length is 6. And these 2 points are midpoints, which would mean it would be half the base. So this length here will be 12. We also know in a rhombus, the diagonals perpendicularly bisect each other. So if this yellow length is 6, this full length will be 12. So this length is 6. So for triangle A, B, C, D, and O. For triangle AOB, can you see one of for a right angle triangle, the hypotenuse is 10, one of the sides is 6, so the other side AO will of course be 8. So area of this triangle, whatever I get here, it will get replicated 4 times. So it will be 4 into half into 8 into 6. So it will become 2 into 8 into 6, or the area will be 96 square centimeter, or option C will be the right answer. Next, each side of a given polygon is parallel to either x or the y-axis. The corner of such a polygon is said to be convex if the internal angle is 90 degree, or concave if the internal angle is 270 degree. If the number of convex corners in such a polygon is 25, find the number of concave corners must be. Okay. Before we go into what needs to happen here, see what sort of diagram is getting created. Now, each side of a given polygon is either parallel to x-axis or y-axis. So the sides will get created this way. Let me use a proper line only. The sort of shape being talked of, hopefully you understand, is like this. Something like this polygon. Can you see every angle here is either 90 degree or it is 270 degree. Every angle that gets created is either 90 degree or 270 degree. This is the sort of shape that gets created. fun thing is, even if you don't know what sort of shape is getting created, this question can still be solved. The question can happily still be solved. Let's see how that would go down. Let's say there are convex vertices and there are concave vertices. Let there be x convex vertices and let there be y concave vertices. Can I say some of the internal angles for convex vertex? The internal angle is 90x, and for concave vertices, the internal angle is 270. This would be the sum of their internal angles. And for a polygon, we also know sum of internal angles is given by number of vertices minus 2 into 180. So x plus y minus 2 into 180. You also know this. Both of these are expressions for sum of internal angles. So we can equate them. Now we can get rid of 90 across the terms. I get x plus 3y is equal to 2x plus 2y minus 4, or x is equal to y plus 4. We come to this expression. Now we are told number of convex corners in such a polygon is 25. So this is 25. This is already known to us. If x is known to us, can I come to 25 is equal to y plus 4? So y has to be 21. Number of concave corners must be 21. Now why I have gone ahead and done this separately is just to show you. For such questions, very often the solution simply says the number of concave corners must be 4 less than number of convex corners. Why that happens? People rarely go into that description. This is the reason why that happens. If you can understand this, the answer to this question is very straightforward. Okay, next question. In a regular hexagon, A, B, C, D, E, F, O is the meeting point of the larger diagonals of this regular hexagon. Find area of triangle, blah, blah, blah. Okay, first, let me try to draw a regular hexagon. Okay, this is my regular hexagon. Deal with it. Now, I'm also going ahead and replicating it several times over because the diagramming would be easier to see. I shouldn't have replicated it so soon. First thing we'll do is we'll name the vertices A, B, C, D, E, and F. Okay, O is the meeting point of all the larger diagonals of this regular hexagon. Remember, a regular hexagon is composed of 6 equilateral triangles. So essentially, the top point of every equilateral triangle, this point is named as O. Now, we're told, let me also go ahead and make these lines. The longer diagonals are these. I am not making proper lines. I'm making lines freehand. Six equilateral triangles. Their top vertex is O. Okay. Now I can replicate it. One, two, three, four. Okay, 4 things I get. 4. Okay. Now, first thing they've asked me is, these are 6 identical equilateral triangles that are meeting. Area of triangle A was. can I say if I take the area of triangle AOF as 1, this is fine. Now area of triangle AED, for AED, okay, I'm drawing this line. Can you see AFEO is pretty much a rhombus? AFEO is pretty much a rhombus. All four sides are identical. So AE is the diagonal. If it is the diagonal, it will divide area of AFOE. It should be 2. If AFO has an area of 1, FOE will also have an area of 1. So AFEO's area of 2 has been divided equally into 2 parts, 1 and 1. So this is an area of 1. This is an area of 1. And OED has an area of 1. So for AED, the area of triangle AOF was 1. Area of triangle AED will be 2. Will be 2. This would help us rule out these two options. Next is area of triangle AEC. Let's see. This is one line. This is another line. And this is another line. This time, look at the rhombuses that are getting created. This will have an area of 1. This will have an area of 1. Then look at this rhombus, OCDE. Again, area will be half in each instance. This will have an area of 1. This will have an area of 1. And then finally, I'm guessing some of us would also already be seeing this rhombus, this rhombus. This will have an area of 1. This will have an area of 1. So area of triangle AEC will be 1 plus 1 plus 1. Or area of triangle AEC will be 3. And finally, area of triangle FEC. Again, FEC if I'm looking for. Can you see? FEC has been made in the precise same way that AED has been made. This FOE has an area of 1. OCE has an area of 1. And CED has an area of 1. So FCE will have a combined area of 2. So the final ratio we get is 1:2:3:2. Or option B will be the right answer. Option B will be the right answer. Okay. This is simply figure watching. This is simply figure watching. Next, in a regular octagon, PQRSTUVW, each side is of length 2 cm and XYUT is a square such that points XY are inside the octagon. Find the area of the hexagon PQRXY. Okay, very, very interesting. Now, I don't know how we make our regular octagons. How I make it is the format I'm showing you. From a square, 4 corners get cut off and a regular octagon gets created. Okay. I will erase bits that are, let me use a large eraser. Oops. Now get rid of these corners. Of course, this is not what I expect you to do in the exam. Freehand drawing in exam is good enough. Here I'm trying to be a little more explanatory in nature. Okay, let's say P, Q, R, S, T, U, V, and W. This is how our octagon currently looks like. And length of each side is 2. XYUT is a square such that points X and Y are inside the octagon. So we need to create a square which has two sides X and T. So XYUT. So this will be X, this will be Y, this will be U, this will be T. Now, next, XYUT is a point. Points X and Y are inside the octagon. Find the area of the hexagon PQR XYW. PQR. Connect these lines now. And go ahead and find out the area of the hexagon created here. Okay, wonderful thing. First thing, we know about regular octagon. The interior angle of a regular octagon. The interior angle of a regular octagon will, of course, be 135 degrees. So utilizing that, can I say, if this is 90 degree, this angle here is 45 degree. And this angle here will be 135 degree, which would imply WYUV is a parallelogram. WYUV is a parallelogram. Okay. This is of length 2. This is of length 2. So, can I also get to area of hexagon this now? I'll come to that area later. First, I want to draw a line here, or from W to R. Look at this shape. Look at this shape. PWYXRQ. This. Can I say the line from P to Y and the line from Q to X, they will of course be identical, because this is 135, this is 45. This is parallel to this. I go ahead and combine these two. I will get 90 degree here, 45 degree here, 45 degree here. WV is parallel to YU. So this is 45, this is 135. This will be 45. This will be 135. This is 90. This is 90. So this will be 45. This will be 90. This will be 45 again. This will be 90. Okay. Remember, this length was 2. And WVUY is a parallelogram. If this is 2, this is also 2. PWY is a right-angled triangle. PWY is a right-angled, isosceles right-angled triangle. If this is 2, this is 2. Length of PY will be how much? Length of PY will be 2 root 2. Similarly, length of QX will be 2 root 2. So now, essentially, see what we are looking for. Area of rectangle PQXY. Area of triangle PQXY, whose length is 2, breadth is 2 root 2. So we have 2 into 2 root 2 plus, look at the area of this triangle PWY. Area of this triangle will be identical, PWY and QRX. So 2 times of half into 2 into 2. So from here I get 4 root 2 plus 4. This should be the area of the hexagon PQRXYW. Answer will be option C for this question. What this question demands of us is the ability to draw a diagram, then look at the angles and then work it around. Of course, there could potentially be, there will be those of us who remember the area of, if you remember the formula for area of an octagon, if you know the area of an octagon, then perhaps you can go ahead and get the area of this square, get the area of this parallelogram also. Area of this parallelogram is also easy enough to do. If this is 2, this is 2, this is 45. We know area of half the parallelogram, so full parallelogram. Half the parallelogram, so full parallelogram. So from the total area of the octagon, we can remove the area of this square and these two parallelograms. Then you'll get the area of the hexagon. Maybe you can proceed that way, but because I don't have top of the mind recall for area of octagon, I will choose to break it down into smaller shapes that I'm more comfortable with, and then proceed. Next, two vertices of a regular pentagon, smaller polygon, connect with two vertices of a regular hexagon, larger polygon, as given in the figure below. What is the measure of angle X? Pay attention, people. This is the boundary of the hexagon. This is the boundary of the hexagon. Now, for a pentagon, every interior angle, regular pentagon, every interior angle is 108 degree. For a regular hexagon, every interior angle is 120 degree. So, for the pentagon, this is 108 degree. And given it is regular, this angle and this angle together, these two sides will be equal, which would mean this angle is 36 degree. This angle is also 36 degree. Now, if this is 36 degree, the rest of it will be 72 degree. For the pentagon, every angle is supposed to be 108 degree. This is 36 degree. This angle here will be 72 degree. And this is a part of an internal angle of the hexagon. Hexagon, the internal angle is 120 degree. This is 72. This X will have to be 48 degree. And that is the answer to this question. Okay. Next, in the figure below, angles ADC and BCD are right angles. This is 90. This is 90. AB has a length of 30. AD has a length of 60 and CD is 5. If CD is 5, I drop a perpendicular from B to D, let's say at point N. If this is 5, look at triangle ABM. One of the perpendicular sides is 5, the hypotenuse is 30. So base has to be 12. Now I know AD is overall 16, so MD will be 4. And if MD is 4, BC is also 4. They're asking me for perimeter of quadrilateral ABCD. It will be 13 plus 16 plus 5 plus 4. Altogether, we will arrive at the answer of 38. The length or the entire perimeter of the figure will be 38. Next, ABCD is a rectangle. DF is perpendicular to EC. C is 30. What is the area of rectangle ABC? Okay. This is one of the funnest questions. First, join DE. Now look at area of DEC. Area of DEC will be half into DF into CE, which is equal to half into 20 into 30, which should be equal to 300. Now, DEC is also a triangle between two parallel sides of a rectangle. DEC is also a triangle between two parallel sides of a rectangle. I'm also dropping a perpendicular from E on DC. Can you see? This area and this area will have equal area. And this area will have equal area. What I mean by that is EDN and EDA will have equal area, and ENC and EBC will have equal area. So if EDN and ENC add up to 300, the area of the entire rectangle is 600, or the answer to the question is option C. Next, ABCD is a parallelogram. Let me draw a parallelogram. Where are you? ABCD is a parallelogram. A, B, C, and D. D is a point on AB such that AB is to BB is 3 to 2. AB is to BB is 3 to 2. So, wonderful. This is 3K. This is 2K. Q is a point on CD such that CQ is to QD, 7 is to K. This is 7Y. This is 3Y. Okay. Now, because this is a parallelogram, can I say 10Y is equal to 5K? 10Y is equal to 5K. So instead of working with variables, can I simply go ahead and say, let me take side AB of this parallelogram is 10. So this is Q, this is P, this is 7, this is 3. And these two side lengths here, AP and PB, also I'm taking as 6 and 4. No problem at all. Next, if PQ intersects AC at R, AC will be here, then PQ will be here. PQ intersects AC at R. Okay, then find the ratio of AR is to AC. Okay, first thing, see this. This angle will be equal to this angle, vertically opposite angles. This angle will be equal to this angle, alternate interior angles, which means ATR is similar to CQR. These two triangles are similar. And we also know the ratio of the length of the sides. AP by QC. AP by, let me write it properly, CQ is equal to 6 by 7. So can I also say AR by CR should also be 6 by 7. But if this is 6K and this is 7K, this is not what the question asked. Question asked for AR by AC. AR is still 6K, but can you see AC is turning out to be 13K? Or the final ratio of AR is to AC is 6 is to 13. Okay. Next, ABCD is a rectangle inscribed in a circle of radius 5 cm. One of the sides of the rectangle is 8 centimeters long. Find the area of the quadrilateral formed by joining the midpoints of the sides of the rectangle. Okay. First, let me draw a circle. Now, within this circle, we have something fun happening. ABCD is a rectangle inscribed in a circle of radius 5 cm. Now, see this here. The diameter of the circle and the diagonal of the rectangle will overlap because the angle subtended by the chord here is 90 degrees. This has to be the diameter, this has to be the diagonal. Okay. And this will have a length of 10 because this is the diameter. If radius is 5, this will be 10. Additionally, one of the sides of the rectangle is 8. This side is 8. It means this is 6 now. This is 6. For the rectangle, the two dimensions are 8 and 6. Next, they've asked me find the area of the quadrilateral formed by joining the midpoints of the sides of the rectangle. Okay. First thing I'm doing is I'm getting rid of this. Then what I'm doing is I'm getting rid of this. Now, they've asked this rectangle, this quadrilateral I have, a rectangle I have, of sides 8 and 6. Find the area of the quadrilateral found by joining the midpoints of the sides of the rectangle. Can I go? If I join the midpoints of the sides of this rectangle, I can of course calculate it. No problem at all. From the total area of 48, this will be 4, this will be 3. So 3 into 4 is 12, 12 by 2 is 6. So this has an area of 6, this has an area of 6, this has an area of 6, this has an area of 6. I can of course, from 48, I can remove these 4 6s and arrive at my answer of 24. This is the maths part of it. Otherwise, what you can also see is if I join these midpoints and these midpoints, can you see I've gotten 4 smaller rectangles? The portions I'm excluding are half those smaller rectangles. So half of the total rectangle has to be the area. So half of 8 into 6 has to be the area. But 24 has to be the area. 24 has to be the area. Okay. Next question now. The quarter circle has a center C and radius equal to 10. If the perimeter of the rectangle CPQR is 26, then the perimeter of, look at this journey that we are going on. A, P, R, B, U, and A. We're looking for perimeter of this shape. Okay. First thing, given that radius is 10, CQ should be 10, and this is a rectangle. It's a rectangle in front of us. If CQ is 10, PR is also 10. So this length is 10, known to us. Additionally, we are told perimeter of rectangle CPQR is 26. CPQR perimeter is 26, which would mean these two sides, let's call them A and B. A plus B should add up to 30. Can I say this full length CB is equal to 10? It is the radius. So BR should be 13 minus 8. Similarly, AC should be 10. So AP will be, how can I reach 13 minus 8? It will be 10 minus 8. This will be 10 minus A, and this will be 10 minus B. Okay. Now, AB DR or ABDR, it will be 1 by 4 of the entire circumference, which is 2 pi r. So 1 by 4 into 2 by 10 or 5 pi. This is for arc AB. The perimeter of arc AB is 5 pi. For AB plus BR, and you see we are getting 20 minus A minus B. We know A plus B is 13. So it is 20 minus 13. 7. And finally PR, we know is 10. We simply have to add these 3 portions up together in order to arrive at the perimeter. So the correct answer will be 17 plus 5 pi, or option B will be the right answer. Next, instead of walking along 2 adjacent sides of a rectangular field, a boy took a shortcut along the diagonal and saved a distance equal to 40% of the longer side. Okay. Now, let's say this was B, this was A. So this length here will be under root A square plus B square, under root A square plus B square. If he had traveled along the edges, he would have traveled A plus B. But because he traveled along the diagonal, he traveled A square plus B square, and he managed to save a distance equal to 40% of the longer side. So from this distance, he managed to save 2 by 5 of A. This gives me the length of the diagonal. Okay. So let's make this as 3A plus 5 plus B is equal to under root A square plus B square. Or I'll write it as 3A plus 5. Let me square it up. I will get 9A square by 25 plus B square plus 6AB by 5 is equal to A square plus B square. I can get rid of B square. I can get rid of B square. I can get rid of A's everywhere. Now I will have this goes over to this side. 16A. 16A by 25 is equal to 6B by 5. Cancel, cancel. 5, 3, 8. I finally need shorter side to the longer side. No, B was the shorter side. So B by A will be equal to 8 by 15. Or option C will be the right answer. This way, technically, it can be so. But now, for such questions, when you have options given, please see, you would have reduced your work tremendously. Simply looking at this wonderful thing, 40% of the longer side, 40%, which means our longer side should be a multiple of 5, or at least try to be a multiple of 5. Among the available options, the only one where you can see the longer side is a multiple of 5 is where it is 15. Happily check. If this is 15, if this is 8, Pythagorean triplet wise, it will be 17. 15 plus 8 is 23. It is 17. 6 less, which is indeed 40% of 15. Therefore, option C is the answer. Straight away, you could have marked instead of going down the equation route. But then, for those of us who want to do it properly or technically, you can, of course, do it this way. Otherwise, simply by checking options also, you could have arrived at the answer. Okay, next question. Two pairs of parallel lines divide the rectangle into 9 smaller rectangles. The area of the original rectangle is A. The area of the rectangle in the middle is A0. The area of the quadrilateral ABCD will be. Okay. Now see, this is a visualization question. This is an amazing visualization question. Look at this rectangle that I am marking. Look at this rectangle that I am marking. Can I say these two portions will have equal area? These two portions will have equal area. Now, look at this rectangle that I'm marking with a yellow line. Can I say these two will have equal area? Or let me not use a tick because tick was used earlier. Let's say the area for this rectangle here, or sorry, these two. This is a diagonal of this. So these two sides will have equal area. Also, AB is the diagonal. These two sides will have equal area. Let me now have this rectangle. Again, these two regions will have equal area because DC is the diagonal. By now, perhaps you know of my game. I will finally take up this rectangle. You can see this will have an equal area. These two will have an equal area. Shapes wise, if you can divide it this way, the work is so much easier. Now, the area of quadrilateral ABCD, can I say it will be area of the full triangle, rectangle, area of the full rectangle minus area of this shaded portion in between, half of that plus area of the shaded region. Area of the full rectangle is 2 ticks, 2 triangles, 2 circles, and 2 stars. But then this is when I have excluded the central area of A0. This area is A0. From A, when I exclude A0, whatever is left, half of that plus A0 will be the area of quadrilateral ABCD. So if I simplify this further, I get A minus A0 plus 2A0 which term by 2 is to a plus a0 by 2, or the correct answer will be option B. Correct answer will be option B. Now, you could also potentially have avoided this all. You could also potentially have avoided this all, or at least an alternate way, which is by no stretch of imagination easier. It is just as in, which is by no stretch of imagination easy, but it would perhaps be easier for you to accomplish if you went ahead and did this. Let me make a square keep all these lines very symmetrical. Now, what would happen? This is A, this is B, this is C, this is D. I'm joining these lines, joining these shapes. If I took side of the larger square as 3, the area of the full rectangle will be 9. A is equal to 9. A is equal to 9. And each of these smaller squares will have an area of 1. Each of these smaller squares will have an area of 1. Now, look at this. This is 1, 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 this is 1. Now, this has an area of 1. Look at A is 9, A0 is 1. Now, let's name this M, N, O, and P. Area of triangle A and B will be 1, half into 2 into half into 2 into 1. So area of this region is 1, area of this region is 1. Or I don't even need this area. This region is 1. Similarly, area of B and C will also be 1. Area of DCO will also be 1. Area of APD will also be 1. So, from total area of 9, I have to exclude 4, or I have to arrive at 5 as an answer. A minus 2AO, 9 minus 2 by 2. Does it lead me to 5? No. Is this equal to 5? No. A plus AO by 2, 9 plus 1 by 2. Is this equal to 5? Very much so. A plus 2AO by 2 leads me to 9 plus 2 by 2. This is equal to 5.5. No. And A minus AO, this is 8 by 2. This is equal to 4. No. The only acceptable answer choice will then be B. You could perhaps solve it this way as well. And here, all I have done is, one of the earlier thoughts mentioned, I have simply deformed the shape. Here, this rectangle is huger, this rectangle is smaller, then this rectangle is slightly huger. We don't know how it has been distributed. But there has not been an instruction as to the top rectangle has to be greater in breadth, the next rectangle has to be smaller in breadth. We can equally distribute it. So 1, 1, 1 distribution will also lead us to the right answer. Option B would still work. Okay. Next. In the figure, ABCD is a rectangle formed by 5 squares, each of side 4 cm. BD is a diagonal. Find the area in centimeter square of the shaded. I'm feeling a little edgy. So what I will do is I'll simply state this. Can you see this shape and this shape will add up to make 1 square? Similarly, this shape will add up to make 1 square. And this is half of a square. This is half of a square. This line is very, very symmetrical. This BD line is, of course, cutting it entirely. If I were to take this small part up and put it here, it will fit precisely. If I take this small part up here and put it here, it will fit precisely. So, half the area of this full rectangle. What is the area of this full rectangle? 5 into 4 square. Half of that will be by 2. So 80 by 2, area of the shaded region will be 40. This is it. That's all that you need to do for this question. Next, a square is inscribed in the quarter of a circle in such a manner that two of its adjacent vertices lie on the radii at an equal distance from the center, while the other two vertices lie on the circular arc. If the square has a side of length x, then the radius of the circle is. Okay. Is there a way I can make radius? No. So I'd have to. Oh, maybe I can. I'll be lazy and make the full circle and then do the one. I'm only concerned with one quarter two. How they've decided or defined it is a square is inscribed in the quarter of a circle, so only this quarter, such a manner that two of its adjacent vertices lie on radii. So this point, I will have side of the square line. But then these are very, very close together. Just imagine this is a square. Despite its appearance, just imagine this is a square. Okay. Okay. While the other two vertices lie on the arc, if the square has a side of length x, this is x, radius of the circles. Wonderful. See how we have to go about doing it is, if this is x, can you see this is a 90-degree angle here because meeting point of two diameters quadrant is being defined. This will be 45. This will be 45. So this length here will be x by root 2. This length here will also be x by root 2. These two lengths are x by root 2. The next part is slightly tricky. You have to drop a perpendicular from this point. Again, this is x. This is 90. This is 45. This is 90. So this will also be 45. This is a perpendicular drop. So this is also 45. Again, if this is x, this will be x by root 2. This length here will be x by root 2. Now, you have to join these 2 points. This point, I join the center of the circle. Look at this triangle that I am demarcating with 3 points. Can you see the hypotenuse is now the radius? And it will be one side of the triangle is x by root 2 plus x by root 2. One side is x by root 2. What will be the radius? It can be figured out. X by root 2 plus x by root 2 is root 2x whole square plus x by root 2 whole square is equal to radius square. So 2x square plus x square by 2 is equal to r square, or 2.5 x square is equal to r square, or r is equal to x times of root 2.5, which is option B. Okay. Next, in the figure below, the rectangle at the corner measures 10 centimeter into 20 centimeter. The corner of a rectangle is also a point on the circumference of the circle. What is the radius of the circle in centimeters? Okay, this is one of the easier questions. I'm sure if you have studied properly, you would have come across this question earlier. If you haven't, just with the fear that you haven't, I have included this. Let's look at this. If this is 20 and this is 10, can I say this length here will be, this entire length is R. This entire length is R. So this will be R minus 10. Additionally, this length here will be R minus 20. This is R minus 20, this is R minus 10, and this is R. Now you can apply Pythagoras theorem and arrive at your answer. Or you can also see this. The only Pythagorean triplet where the three sides are in AP is the 3, 4, 5 triplet. The only Pythagorean triplet where the three sides are in AP is a 3, 4, 5 triplet. And here you can see three sides are in a Pythagorean triplet, as in Pythagorean triplet, and are also in AP. The three side lengths you can directly jump to will be 30, 40, 50. Otherwise, of course, you can utilize this R minus 20 whole square plus R minus 10 whole square is equal to R square. So we get R square plus 400 minus 40R plus R square plus 100 minus 20R is equal to R square. So cancel, cancel. We get R square minus 60R plus 500 is equal to 0. So R is equal to 10, 50. R cannot be 10. R has to be greater than 20 and 10 because it is greater than that, and therefore the correct answer will be option C, 50. You can solve it this way. Otherwise, you can simply know the only Pythagorean triplet in which the three sides are in AP in an arithmetic progression is the 3, 4, 5 Pythagorean triplet. So if I have 10, 20, 50, if I have R minus 20, R minus 20, R minus 10, and R, I directly can jump to 30, 40, 50 are the three side lengths. Okay. Moving on. Next, ABCD is an isosceles trapezium. ABCD is an isosceles trapezium. AB is 2 units. AB and CD is 14 units. Okay. This is 2. This will also be 2. Given that the total is 14, if 2 is gone, equally it will get divided because this is an isosceles trapezium. So this will become 6, and this will also become 6. Okay. BC is given to us as 10. So this is also 10. So let's call this point M, let's call this point N. AM will therefore be 8 and BN will also be 8. Okay. The midpoints of the sides of the trapezium are joined to form the quadrilateral PQRS. Let's join the midpoints. PQRS, this is P, this is Q, this is R, this is S. Find the ratio of area of the circle inscribed in the quadrilateral PQRS to the area of trapezium ABCD. Okay. First thing you need to know, we know this figure that gets created here. This figure that gets created here. One diagonal is 8 from P to R. That length is 8. If AM is 8, TR is also 8. TR is equal to 8. Also, let's look at SQ. What will be the length of SQ? SQ will be equal to AB plus BC by 2. This is the midpoints of the oblique sides. But the line joining the midpoints of the oblique sides is the average length of the two parallel sides. This is also 8 centimeters or 8 units. AB is 2, DC is 14, so D is 14, 16 by 2. This is also 8. So we pretty much have this shape. 8 centimeters and 8 centimeters and this is P, Q, R, S, 8 centimeters, 8 centimeters. This is 4. This is also 4. This is also 4. This is also 4. Okay. Now, wonderful thing. See, ratio of the area of the circle inscribed in quadrilateral PQRS. The circle that gets inscribed here will be like this. It will be tangential to this side. This is a right angled triangle. This is 4. This is 4. Can I get to, so this will be 4 root 2. Can I get to this radius? Half into 4 into 4 is equal to half into radius into 4 root 2. So half and half gone, 4 and 4 gone. We are left with R is equal to 2 root 2. R is equal to 2 root 2. So area of the circle inscribed will be pi R square. So 4 and 8 pi. Area of the circle inscribed is 8 pi. Now area of the trapezium ABCD is going to be half into sum of parallel sides 16 into the height, which turns out to be 8. So we get to 64. So the final ratio is 8 pi by 64, which will be equal to pi by 8, or option D will be the right answer. Okay. Now, next question. Consider a square ABCD with midpoints EFGH on AB, BC, CD, and DA respectively. This is a square ABCD. Okay. Let me name the points A, B, C, and D. And I also need midpoints now. E, F, G, and H. F. Let L denote the line passing through F and H. I definitely need to reimagine my point H. In fact, let me do this. Let me draw a line. Okay. Wherever it ends at, this is H. This is H. Okay. Consider points P and Q on L inside ABCD such that angles ABD and BQC both are equal to 120 degrees. So now see. Okay. This is P. This is Q. Okay. Now, this is 120 degree. This is 120 degree. Cool. If this is 120 degree, also see the line passing from here. These two side lines will be equal. These two side lines are equal. So this will be 30. This will be 30. This is an isosceles triangle. This is the median to the base. So this will be 60. This will be 60. This is 90. This is 90. And the same thing would happen on the other side. Now, if it is 30, 60, 90 triangle, we know length of sides. I can give it 1 root 3, 1 root 3 and 2. Area of this triangle will be root 3 by 2. And I have 4 such triangles. Area of this triangle will also be root 3 by 2. Area of this triangle will also be root 3 by 2. Area of this triangle will also be root 3 by 2. Additionally, if AH is root 3, HD will also be root 3. Okay. Finally, they've asked me what is the ratio of area of ABQ CDP, ABQ CDP, this portion, to the remaining area inside ABCD. Can I say area of ABQ CDP will be area of the square minus the areas of the smaller triangles outside? Area of the square will be 2 root 3 whole square minus 2 root 3. Root 3 by 2, root 3 by 2 gives me a root 3. Root 3 by 2, root 3 by 2 gives me a root 3. So, area of A, B, Q, C, D, P, A will be this much divided by 2 root 3. I can happily get rid of root 2 root 3 from everywhere. And I'll have 2 root 3 minus 1 left, which is indeed the final option. So, the correct answer to this question will be option D. I hope you learned something. My diagramming skills are not that great, so I'm making use of lots of tools in order to display it nicer. Otherwise, even with reasonably poor diagrams, you can get to the answers. That is never holding us back. Hopefully, you learned something. That will be all for this week's QQQ. Okay, bye.